The Foundations of Geometry by David Hilbert. Chapter 1. The 5 Groups of Axioms. Section 8, Group 5, Axiom of Continuity, Archimedean Axiom. This axiom makes possible the introduction into geometry the idea of continuity. In order to state this axiom, we must first establish a convention concerning the equality of two segments. For this purpose, we can either base our idea of equality upon the axioms relating to the congruence of segments and define as equal the corresponding congruent segments, or upon the basis of groups 1 and 2, we may determine how, by suitable constructions, see Chapter 5, Section 24, a segment is to be laid off from a point of a given straight line so that a new, definite segment is obtained equal to it. In conformity with such a convention, the axiom of Archimedes may be stated as follows. Let A1 be any point upon a straight line between the arbitrarily chosen points A and B. Take the points A2, A3, A4, and so on, so that A1 lies between A and A2, A2 between A1 and A3, A3 between A2 and A4, etc. Moreover, let the segments A sub 1, A sub 1, A sub 2, A sub 2, A sub 3, A sub 3, A sub 4, and so on, be equal to one another. Then upon this series of points, there always exists a certain point, A sub n, such that B lies between A and A sub n. The axiom of Archimedes is a linear axiom. Remark: to the preceding 5 groups of axioms we may add the following one, which, although not of a purely geometrical nature, merits particular attention from a theoretical point of view. It may be expressed in the following form. The axiom of completeness, Vollständigkeit. To a system of points, straight lines, and planes, it is impossible to add other elements in such a manner that the system, thus generalized, shall form a new geometry obeying all of the 5 groups of axioms. In other words, the elements of geometry form a system which is not susceptible by extension if we regard the 5 groups of axioms as valid. This axiom gives us nothing directly concerning the existence of limiting points, or of the idea of convergence. Nevertheless, it enables us to demonstrate Bolzano's theorem, by virtue of which, for all sets of points situated upon a straight line, between 2 definite points of the same line, there exists necessarily a point of condensation, that is to say, a limiting point. From a theoretical point of view, the value of this axiom is that it leads indirectly to the introduction of limiting points, and hence renders it possible to establish a one-to-one correspondence between the points of a segment and the system of real numbers. However, in what is to follow, no use will be made of the axiom of completeness. The Foundations of Geometry by David Hilbert. The material contained in the following translation was given in substance by Professor Hilbert as a course of lectures on Euclidean geometry at the University of Göttingen during the winter semester of 1898 and 1899. It was translated by E. J. Townsend, Ph.D., University of Illinois. The text was downloaded from Project Gutenberg with the following notice. This ebook is for the use of anyone, anywhere in the United States and most other parts of the world at no cost and with almost no restrictions whatsoever. Read by Jim Wrenholt. Programming and illustrations by Jim Wrenholt. 2019. Portrait of David Hilbert by Reida Wrenholt. Thank you for listening.